Yeah, good morning, students. Myself S.J. Varaprasad, working as an assistant professor in BBC College of Engineering. So, I'm dealing with the subject electronic circuit analysis. Today's topic about feedback amplifiers, which is an important topic for designing of an amplifier. So these are the contents. Firstly, we'll go with the definition of feedback and what are the types of feedback. Nextly, advantage. Basically, there are advantages only for negative feedback as compared to positive feedback. The nextly very important topic about feedback topologies and their analysis, and from that we can go for conclusions. So let me discuss what is meant by feedback amplifier. Actually, the feedback amplifier is a circuit which consists of two main circuits there. One is feedback circuit, another one is amplifier circuit. As you know that the amplifier circuit is just to amplify the signal, and the purpose of feedback circuit is why we are going for feedback is explained now. First of all, I would like to explain why the feedback circuit, what it consists of. So feedback circuit is essentially a potential divider. That means it just consists of resistors which acts as a potential divider. The purpose of feedback, as you know, that it drags some part of output and given back to the input. This is a correction mechanism which is needed. So in this figures I already mentioned that the feedback is the mixer circuit, and here there we go. This is our amplifier, basically in a transistor, or we'll go with op amp also. This is the output signal. If you observe carefully, the output is dragged with the help of a feedback network which consists of beta, where it's nothing but a set of resistors, and given this back to the input. So that feedback fraction is nothing but a output of ratio of output to feedback. So from the potential divider we can draw this conclusion: beta is nothing but R2 by R1 plus R2. So that is the basic definition, and now we go with the types of feedback. So the feedbacks are classified into two types. One is negative feedback and positive feedback. Both positive and negative feedbacks are used in amplifier designing. So more comparatively, the negative feedback is having more advantages. So I'll explain what is the negative feedback and the positive feedback. So if the feedback signal and the input signal are opposite to each other, that means they are out of phase, then that type of connection is called as negative feedback. And in a similar way, if the feedback connection and the input signal are in similar phase or in same phase, then they'll add with each other, then the type of feedback gives the positive feedback. There I'll draw the analysis, I'll draw the conclusion there. So this is the gain after feedback, AF, which is also called as a closed loop gain, where A is just the open loop gain or simply gain of the amplifier. So this is the expression for gain after feedback for negative feedback amplifier. In a similar way, we'll get the definition derivation for this one, positive feedback also, but in the answer we'll get A by 1 minus A beta. So which is an essential thing in the derivation of and analysis of feedback topologies. Advantages, yeah. There are many advantages of negative feedback. Some are listed here. Gain stabilization is one thing. So this is independent upon open loop gain. That means AF is independent upon A. So that it is depending upon only the beta, what is called as a feedback network, which consists of resistors which are fixed. So that's why gain stabilization is one of the advantage. And secondly, the main important, nonlinear distortion and noise both can be reduced after giving the negative feedback. And one more important thing, input and output impedance can be controlled by using a negative feedback amp. And lastly, there is an extension of bandwidth. So taking all this consideration, so we conclude that negative feedback is very essential and very useful in designing. and some correction mechanism deriving and for some correction mechanism. So nextly, the feedback topologies are basically classified into four types: voltage series, voltage shunt, or current series, and current shunt. There I'll draw, or here it is given that AF for all the feedback topologies. One more important thing, the name voltage series defines that the first word represents the output and the second word represents the input and feedback. For series, we'll go with the voltage, and for shunt, we'll go with current. That means four signals we have to consider: input signal, output signal, feedback signal, and the source signal. So input is nothing but our source. If the input is voltage, the source is also voltage. The first thing, voltage. So first letter is on a sampling, output sampling, and the second letter is the mixing. What type of mixing, series or shunt? That will be clarified by seeing the next diagram. So these are the four circuit diagrams, block diagrams for this one. So if you go with this one, A and B, if you observe carefully, the input sides are with the series mixing. Here you find some loop here, and A and C is a parallel output sampling. So node sampling, this node sampling. So based on that, we'll classify the feedback topologies. And actually, I'll go with the analysis. So this is the voltage shunt feedback amplifier analysis. However, voltage gain is for negative feedback. We get the same thing, A by 1 plus A beta. This is the calculation for input impedance and output impedance. Similarly, we go with voltage series. These are the derivative parts of voltage gain, input impedance, and output impedance. And we will go with the current series. This is the derivative way for current series. Or the similar way we can solve for current shunt also, and there we draw the conclusion. So however, gain is decreased because 1 plus A beta term is in denominator, which is nothing but a dividend. So we can that gain is decreased for all the four types of topology. So bandwidth obviously it is also increased. So one more point what we have to remember is, what about input resistance and output resistance? So for series circuit, series is nothing but an joining, cascading, which resultant the improved resistance value. So if you add R1 plus R2, that value will be increased. So for series circuits, the input resistance is increased. For shunt connection, the input resistance is decreased. In a similar way, for voltage, the resistance will be decreased, and for current, the resistance will be increased. So thank you very much. I'll go with the next class with oscillators.